Hello friends, welcome back to all of you on your channel that is on JE Physics Maniac. So here we are starting the next series on the capacitor lecture series that we are doing. So here you can see that a parallel plate capacitor is connected to a battery. So this is the positive side of the battery and this is the negative side. And if I do consider that there is a switch in between, if I consider that there is a switch in between, and let us say this is the switch, right? So if the switch is connected, now when the switch is connected, this battery will start charging the capacitor, right? The moment switch is connected, the battery will start charging the capacitor. So as a result, we will see that positive charges will come over here and negative charges will come over here. Now here you remember one thing, that even if the capacitor has some initial charges, जैसे मान लो कि initially this is given a charge Q1 and this is given a charge Q2. So as part of previous discussion, we know that this outer surface will have a charge of Q1 plus Q2 by 2 and this one also will have a charge Q1 plus Q2 by 2. Now if this capacitor is connected to the battery, in this case on this outer surface no charge will stay. So here on the outer boundary no charge will be there, right? So you should remember that basically this battery over here, I can write the battery works as electron pump, right? So even if some charges are there on the outermost surfaces, the battery in the process of working as an electron pump will negate it, and hence ultimately the charges will come on the innermost boundaries, and hence there will be an electric field concentrated between these two surfaces, and hence it will form capacitance, right? So we know that in this kind of process, energy stored across the capacitor. So here in such circumstance, energy stored U will be given as half CV square. Okay. Remember this particular thing. Why am I writing? Because whenever a capacitor is connected to a battery, so if a capacitor is connected to a battery, then potential difference PD across it, then PD across it is equal to constant. So potential difference across the capacitor will be constant. So if you are learning this particular theory for the first time, there are plenty of things to be remembered, and I suggest you to remember the things the way I am trying to explain, because it is always better to remember the concept rather than misconcept. Although at times misconcept comes easily and it seems they are easy, you will also feel good, but whenever you apply you will be gifted with the negative answer. Anyway, so here energy stored is equal to half CV square. So remember, whenever a capacitor is connected to a battery, we will use this energy equation, and if the capacitor is not connected to the battery, that means in that case charge is constant, so we will use Q square by 2C. So these two equations are different, hence you have to remember in that way only. Now whenever a capacitor, whether it was having an initial charge or it doesn't have an initial charge, if connected to a battery will supply some kind of excess charge, right? So in the process, the battery will do a finite amount of work, okay, and this work done by the battery, WB, is written as Q excess into delta V. You don't forget this. WB is equal to Q excess into delta V. What is excess? That is the extra charge supplied by the battery. What is Q extra? How will you get it? Q extra is definitely the difference Qi minus Qf. The mod value of it is basically Q extra into what is delta V over here? Delta V is basically EMF of the battery. If it is V, it is V. Ultimately, that will also be the potential difference across the capacitor, right? And as we have seen earlier, that also you have to remember, in this entire circuit you cannot see any resistor. So you should remember, without any resistor, if a capacitor is connected to a battery, it will be charged instantaneously. So there will not be any finite time lag for the capacitor to get charged completely, right? So I will just quickly note down the points in bullet format so that it becomes easy for you to remember. The first point to be remembered word, that the battery will act as electron pump and it will make Q outer, that is the charge on the outermost surfaces, is equal to 0. Okay. What is point number 2 to remember? Point number 2 is that if a capacitor is connected to a battery, then energy of the capacitor must be expressed in terms U is equal to half CV square. Third point to be remembered, in the absence of a resistor, a capacitor gets fully charged instantaneously. Okay, a capacitor gets fully charged instantaneously. Okay, what is the fourth point to be remembered? Fourth point to be remembered is that work done by the battery WB is equal to what I have written, Q extra into delta V. And the fifth most important point, that in this process a finite amount of heat will be dissipated and this work done by the battery will be used in two ways. One is to store energy and other is to dissipate heat across it. So from there, delta H we can write WB minus of delta U. WB, what is delta U? Delta U here is the change in energy. I can write the initial energy to be EI and final energy to be EF. So hence this delta U will come to be EF minus EI. So these are the bullet points that you must remember before solving questions, right, from this particular topic or this particular discussion. Okay, let's move ahead. We'll see two examples and I will keep today's lecture very short and intact. We will only focus on this particular aspect, that a battery is connected, a capacitor is connected to a battery. Subsequently, gradually we will come for dielectrics, and when all the cases of parallel plate capacitors are completed, then only I will move on to the different other kind of capacitors like spherical capacitor or cylindrical capacitor. Okay, fine, chalo. So let's see an example. Here it is seen that work done by the battery and heat dissipation you have to calculate. So we will do. So let us first calculate what is the initial charge on the capacitor as the battery is disconnected initially at t equal to 0. At t equal to 0, switch is off. It is in off mode. It's not connected. So at that point of time, if I think about the capacitor, so let us think about the capacitor. For the capacitor, it is if it is 2C and it is 3 volt, so we can write simply that I will try to keep it more intact actually. So instead of writing this 2C and 3V, I will keep this as 2 microfarad, right, and this is 3 volt. So it becomes here the charge will become plus 6 microcoulomb and this is minus 6 microcoulomb. So that's the situation we can see when the switch is off. Now when the switch is connected, now once the switch is connected, let's see what happens. So once the switch is connected, what will happen, we want to understand. So in this case, when the switch is connected, so the battery will develop potential difference of 10 volt across it, right? So now the configuration of the battery will be changed, a capacitor will be changed. So now the potential difference across it becomes 10 volt. Capacitance still remains to be 2 microfarad. So what is the charge now across it? So it will become plus 20 microcoulomb and minus 20 microcoulomb. So what is the Qi initial charge in the system is plus 6. What is Qf final charge on the plate is plus 20. So now from here you can imagine what is the Q extra, how much charge the battery has supplied. Q extra is equal to, I can bluntly write Qf minus Qi. How much is that? This 20 minus 6, that is equal to 14 microcoulomb. So this is the amount of charge that the battery has supplied extra to the capacitor to get it charged completely. So what is work done by the battery? Work done by the battery is equal to Q extra is equal to 40 into 10, that is equal to 140 microjoule. So 140 microjoule is the work done by the battery. So next what they are asking what is the heat dissipation. For heat dissipation we have the formula. What is the formula? Delta H is equal to work done by the battery minus of EF minus EI. We will do one by one. Work done by the battery already we got, this is equal to 140 microjoule. I want to calculate EI. So if I want to calculate EI, initial charge on plate was 6 microcoulomb and the capacitance is 2 microfarad. Since it is not connected to the battery, so I will take Q square by 2C. So half into 6 into 6 divided by 2. So that is, this is 3, this is also 3. So that is 9 microjoule. Okay, is that clear? Q square by 2C. Okay, so that is the initial energy of the capacitor. What is the final energy? In the same way, EF. Now in this case the capacitor is connected to the battery, so that means potential difference constant, so we will be using half CV square. So half into 2 into 100, so it becomes 100 microjoule. So final energy of the capacitor is 100 microjoule. So if I call this as equation number 1, then I can write from equation 1 delta H, how much it becomes? Work done by the battery is 140 minus EF. EF is how much? 100 minus of EI. EI is equal to 9. Okay. Is that fine? Is it clear? Okay, na? Right? Check it once. Everyone. Just go to the formula quickly. Alright, fine. So it becomes 140 minus of, this is 91. So it becomes 9 49 microjoule. Okay, so here heat dissipation in this case becomes 49 microjoule. So this should be the final answer. Anyway, I request everyone to go through the calculation and check whether the values we are getting are correct or not, because you know that I always keep on saying that I am a champion on silly mistake. Anyway, yeah, so let's proceed. So here in this case you can see that a situation is given a little bit differently. कैसे? Now first at t equal to 0, अब calculate कर लो at t equal to 0 if this is the capacitor plate. So in the capacitor plate I will also take in the same way. I will take it as, this is 4 microfarad. Alright, so it becomes 4 into 5, that is 20 microcoulomb plus, and this is minus 20 microcoulomb. Okay, so now right after the switch is closed, what will happen if the switch is closed? Immediately the capacitor will have minus plus 10. Now this is minus, this is plus. So how much charge will come here? Since this capacitance remains same, so this will have minus 40 microcoulomb, this will have plus 40 microcoulomb, right? So now you try to understand ki the initial charge on the capacitor was plus 20, from there it came down to minus 40. So what is the extra? How much is Q extra? Q extra is equal to 60 microcoulomb. That you need to understand. So from here, what will be the work done by the battery? That is equal to 60 into 10. That is equal to 600 microjoule. Correct? Now, in the same way, what is the initial energy? EI is equal to, we have to apply Q square by 2C because it was not connected. So 1 by 2 into 4 into Q square means 400. So how much it comes? 150 microjoule. All right, fine. So what is EF? EF is equal to, we can apply half CV square. So that is equal to half into 4. V square means you check 10. So this becomes 100. So that becomes 200 microjoule. So what is delta H then? Heat dissipation formula. We know work done by the battery minus of EF minus of EI. So it becomes work done by the battery is 600 minus of EF is how much? 200 minus of EI is 50. So it becomes 600 minus 150, that is equal to 450 microjoule. So that is the heat dissipated across the capacitor in the process. Correct? So I hope you are thorough with this concept. Now you can do such kind of questions even if there is a little bit question of switching and all that. So the cream thing is that you have to remember these 5 bullet points before attempting such kind of questions. And after working out those examples, I will leave things up to you ki what is the conclusion you are drawing, in what way you are trying to understand such thing, because in the next class I will come up with some more complicated cases and I will try to explore more dimension into the concept that I have taught today, right? So till that time you people keep on practicing quality stuff, right? And as I previously said also, for me confidence is a thing which comes out of engagement, and skill is a thing which is being developed through practice rigorously. Now you will not get confidence by solving 50 or 5000 easy level questions. Rather than, don't think about the outcome, don't think about the answer that you are going to get, but if you spend some quality time in solving or trying to solve one particular good questions from an authentic source or from a good source like Irodov or from any other standard IIT JEE reference book, I think it will serve better quality purpose for you. The only thing for IIT JEE is that you should not lose temperament. You have to be self-motivated throughout the course of your preparation, right? So thanks all. If you like this, please subscribe, share, and please hit the like button. Thanks. Thank you very much.